So hello all, Ajay here. I work for Databricks. I'm part of our field engineering team. I focus on essentially working with our customers and our partners in their adoption of the Databricks platform. So today I'm going to spend the next 15 minutes over here giving you a really quick look into Delta Lake, which brings transaction and reliability to your data lake environment. But before I kind of go in and talk about Delta Lake, just a very quick plug on Databricks on GCP. So Databricks is a data and AI platform. We are today available on other clouds, but we are very soon arriving on GCP. So the public preview will be available on March 22nd. And I cannot wait for this launch to happen, as we are seeing a tremendous excitement in the market and demand from our customers for the GCP platform. But really, the talk today is more about Delta Lake. So let's dive into it. The trend that we are seeing right now in the market is people want to bring the same level of data quality and data reliability to their data lake environment that they come to expect and that they get from their data warehouse environment. Yeah, so really they want to bridge the data warehouse and the data lake into a common architecture, right? That we are calling that we are seeing in the industry now an uptake of this architecture pattern called Lakehouse, right? That really combines the best of both worlds. So what does a Lakehouse architecture really look like? What is it that the customer is really looking for? It's really the best of both worlds, right? In the data warehouse world, you get ACID transactions. You get data reliability. If you end up fat fingering, if you end up accidentally deleting your data, you can easily recover your data. You always have consistent reads of your data. If a transaction fails, you never end up in an inconsistent state or half-dirty data. And you have indexes, so you can not only just scan the data, but you can very efficiently read the data of your data warehouses. On the other side, as you look at data lakes are really good in terms of being able to scale infinitely to any size of data set. They give you the flexibility of schema. They support both batch and streaming reads, and data lakes are based on open formats. Yeah, so it is not a lock-in like a traditional data warehouse where you don't know what the file format is, and you're having to pay the tax of using the data warehouse to get to your own data. Right, so Data Lake brings you that kind of the openness and the freedom to use any tool because the file format is an open format. And how do we really bring these two worlds together? Yeah, how do we enable the transactional capability of a data warehouse with the best of what the data lake has to offer? Yeah, and that really that desire to combine the two led to the innovation of what we call Delta Lake. Yeah, this was at Databricks. Most of the world know us as kind of the original creators of Apache Spark. But really, as we look at all the innovations that has happened at Databricks, this Delta Lake we feel is the most is one of the best work that has happened within Databricks, right? To bring this transactional reliability to the data lake environments. Now let's, before I kind of just talk about, it gives you ACID, it gives you rollback, it gives you snapshotting and so forth. Let's just look at kind of the real life problems that our customers who are using Apache Spark in the cloud, the Databricks platform in the cloud ran into that really led to the creation of the Delta Lake file format. Yeah, so in the end of the day, people have data, right? That could be streaming, that could be batch, that they want to do both streaming analytics and historical analytics and deep learning and AI on top of it, right? That at a very high level defines the data initiatives within any particular enterprise, right? But if you look at how you have gone about implementing it in the traditional big data environment, is the enterprise has to deal with tons of challenges, right? So one, if you want to do streaming analytics and you want to do historical analytics, then you need to have this Lambda architecture. Yeah, I'm pretty sure all of you guys who are out listening, you have heard about the Lambda architecture, where you have the streaming the streaming branch and you have the historical branch. But now you're having to maintain two different sets of code. And the challenge with streaming branches, it's not always the new data. Sometimes you have to go back and recompute your data set, or you have to come up with newer insights. In which case, Kafka is really not the long-term store. And how do you then create those new streaming insights on top of your data, it gets to be really, really challenging, right? Implementing Lambda architecture is way more challenging than what many people kind of make it appear to be so, right? The second thing that you run into with classic data lake implementations is data is never clean, yeah? So you have to now implement data checks, data quality, whether your data complies to your schema or not, and all of that rule now needs to be built into the processing engine, because really the data lake itself doesn't guarantee or doesn't provide any kind of validation as you're writing into these stores. Yeah, now not only are you duplicating your data checks across your streaming branch and your historical branch, you're not really getting any leverage from the system itself, unlike in a data warehouse where you can at the very least say foreign key constraints, you can say not null constraints, and so on and so forth, right? So you get benefits from the underlying system that you don't get in a data lake environment. The third thing that our customers would commonly and often run into is mistakes, failures in small files and partitions. Okay, who has ever written a data pipeline that they have never had to go back and revisit and refine and correct, right? I would guarantee you that there is not one engineer who would stand up and say, my data pipeline, as I wrote on day one, has since worked infinitely, has worked wonderfully well for infinite future, right? Your data changes, your business logic changes, your need for analytics changes, and as a result, you always have to go back and refine your data pipelines. But how do you really do that? You don't have a way to go back in time. How do you correct the data set, right? It gets to be really, really challenging unless and until you're maintaining your entire history forever inside of Kafka, which is not a very practical way to go forward with, right? So you really need a way to be able to roll back data sets and to then be able to replay from a certain point forward. The other thing that we ran into with many of our customers was if you have streaming data and you land it into your data lake environment, you end up with lots of small files, which is extremely painful from a performance perspective, right? So now you have to run all these auto compaction jobs in the background, and you have to do it in such a way that it doesn't come in the middle of while you're doing the analytics, because then you're going to start seeing inconsistent data because half of the data is written and the half of the data is not written. Yeah, so you run into all these kind of mistakes, failure, and small file challenges. And finally, what about updates? Yeah, in the world of GDPR, in the world of CCPA, in the world of CDC, you have data sets that is changing. Your data is not always just append only. And implementing those updates and merges and deletes inside of your data lake environment is a gymnastics. Right, you have to read your table, you have to create temp tables and merge them together. It's just not easy. It's just not easy as it is in a data warehouse world, right? So the whole motivation of Delta Lake was to really we saw these problems with our customers, right? We have customers who have the largest data lake implementations in the world, and solving this is maybe okay on small data set, but solving this at large scale across thousands of customers is extremely challenging. Yeah, and so that led to really the creation of Delta Lake. We saw our customers wasting time and money solving system problems instead of really getting value from data. Yeah. So if we had an ideal table format, what will it really do to support some of those practical life challenges that our customers face, right? So if you look at historical and streaming queries, what if your Delta table, right? If the table that you created on your data lake supported both streaming reads and streaming writes, and as well as batch reads and batch writes, right? Then you don't have to worry about this complicated Lambda architecture. You could just simply land your data into a Delta table and then use it for either streaming or use it for batch, as in when what your requirement calls for, right? So how about if we implement both batch and streaming reads and writes into a Delta Lake table? What about messy data, right? Messy data means that I need to roll back. I need to be able to play forward. I need to have data versions. I need to have constraints and checks built into the system, right? So Delta Lake gives you built-in validation. You can specify for a column to be not null. You can specify additional smart validations. You can say a column has to be in between a certain range. You can even compare columns so that you can say that, by the way, your tax amount cannot be more than the cost of the item itself. Right? Or you can do schema validation, or you can set your system so that the schema evolves automatically as new columns show up inside of your data set. Yeah, all of that gets taken care of by Delta. What about mistakes, failures, and small files? Delta Lake gives you time travel, so you can roll back your data set. It gives you snapshots, so you can get a consistent point-in-time read of your data. It gives you change logs so that you have full visibility into what changes have been made and who has made those changes. And it gives you auto compaction and infinite scalability with regards to partition. You don't have to worry about having 10 partitions, 100 partitions, or whatever the other limits are in other systems. With Delta, you can have infinite number of partitions if that's what really works well for you. Right now, of course, that is not a great idea to have lots of infinite number of partitions, but you don't have an upper limit as in 1,000 or 10,000. You can have hundreds of thousands of partitions with no performance penalty to go along with it. Yeah, so those were, and finally, as to updates, right? Because CDC and merge and GDPR and CCP are realities that every enterprise has to deal with. What about if we give you the full DML support? So you can do deletes, you can do merges, you can do upserts, you can do inserts onto your Delta table, right? So that's really what Delta is. Delta gives you this new standard for building out your data lakes. It brings you the best of data warehouse with all of those asset transactions, time travel, snapshots, compactions built into with the wonders of what data lakes give you, which is infinite scalability and open format. Yeah, so just a couple of quick words. Delta Lake, we started working at Databricks on Delta Lake a few years back. As of today, there are over 3,700 organizations that use Delta Lake. It is a Linux Foundation project, so it's again open source, and very much like Google, we believe we have strong roots in the open source community. We were the creators of Apache Spark. We're the creators of Delta Lake. We're the creators of MLflow. We are the creators of Koalas. And with Delta Lake, we are now across all these organizations, they have processed over 4 exabytes of data in the Delta Lake format. So this is not new. This is not tested. This has been tested at scale with the largest of organizations, right? So if you want to leverage these capabilities on top of your data lake, you can get started now with the confidence that this is well-tested and tried piece of technology that will serve you well as part of your production implementations. Now, how do you get started? Delta Lake is really a Spark package that allows you to do these read and write into a Delta table. But if you want to just do a read, you don't have to necessarily be reliant on Spark. There are open source non-Spark packages that you can use to read data from a Delta Lake, right? So yes, it is available within Spark, but you can also use it outside of Spark. Right. The next question really comes to is how do I get started? Yeah. So if you're using a Databricks environment, right, as I said, Databricks on GCP is going to be available on March 22nd. That's when the public preview goes live. You'll be able to spin it up from the marketplace. Or if you're using a different Spark environment, you can simply import the Delta package into your Spark environment and begin to use and leverage Delta. And as to how much time does it take for you to build the skill? Does it require you to learn a whole lot more? Really not much, right? You have always been using this format called create table using Parquet to create Parquet tables. If you want to create Delta tables, all you have to do is to just say that now I want to use Delta. Yeah. Instead of saying Parquet, you say use Delta, and now you get all the benefits of transactions, reliability, snapshots that come with Delta. Yeah, so it's really easy uptake. It doesn't take a lot of learning to get going on the Delta Lake technology. Okay, and this is another code snippet about doing time travel with Delta. You can roll back. You can read data as of any given point in time, or you can read data as of any given version. And every time you insert or you update your Delta table, there is a new version of that table created and managed. Yeah, just a very quick example of a case study. So Comcast, for some of you guys in the US, and I know that there is an international audience here, Comcast is a large provider of internet provider and TV services provider here in the United States. they use Delta for managing all of their viewer information or viewership information of who's viewing what has been the interaction with their voice with their voice remote systems. And what they saw with Delta was essentially their Delta Lake is petabytes of data. With Delta, because of increased efficiency, they were able to reduce the compute costs from 640 instances to 64 instances, so 10x reduction in compute costs, while they saw improved performance on their end-to-end data pipeline latency. Yeah, so massive benefit was gained at Comcast, and again, there are multiple examples of customers being successful with the Delta technology. Okay, I did have a demo plan for here, but before I go into demo, let me ask Chris. Chris, I know that my time got cut a little bit. Can we go over? Should we really be looking to wrap it up at 11?
No, go for it. If people are interested, they can stay. If they have a meeting separately, that's fine, and we'll keep a recording. If people do have to drop, they can come back and watch the recording. So please, continue on, AJ.
All right, perfect. So team, what I'm going to do next is really kind of give you a live demo. So what I'm going to do is I'm going to switch over to a Databricks environment. And this, by the way, is Databricks running on GCP. Earlier on, I had said that Databricks is coming on March 22nd. As of this point in time, we are in gated public preview. So select customers are already using Databricks on GCP. And you are looking at one of the Databricks workspaces that's running in the GCP environment. So just a very quick before I kind of show you the code, let me give you a quick tour of what the Databricks environment looks like. So you log into the web interface of Databricks, and here you would see that you have some quick on the landing page. You would see some quick tutorials. You will see access to notebooks, tables, and so forth. And without going into every little detail about the platform itself, let me just talk about a couple of things. So one, Databricks is an environment where you can manage data, where you can run compute, whether that's data engineering, data science, or analytics workload. So how do you really kind of provision compute? Is if you go to the clusters page over here, you can go ahead and create a cluster. Right, so every user who's been given the privileges to be able to create a cluster will be able to go ahead and just create a cluster, right? And when you create a cluster, you specify a name, you specify what is the minimum maximum number of workers, and the system auto scales between the minimum and the maximum. And you can also specify for how long should the cluster be up before it auto terminates, right? So if no work is happening, you don't want to have a runaway cost cloud. So you can really just specify auto termination, and in which case the cluster will automatically shut down if there is no workload running within the cluster. Yeah, so really easy to get up to stand up this cluster. And what happens in the back end really is when the user or an administrator creates a cluster, it really in the back end ends up spinning up a GKE node pool, right? So all of Databricks on GCP is actually leveraging the Google's Kubernetes environment. So that's where the compute happens. You need to have a cluster. Now, what gets computed is really the code that you create, right? And the code that you create is created inside of a notebook in the Databricks environment. And we support notebooks that can be Python, Scala, or SQL, or Java, and within a given notebook, you can actually mix and match. You can go shift between Python and SQL or R within the same notebook itself, right? Each of these notebooks are backed into our version control that you can use Databricks built-in version control, or if you want to back it up into your own favorite Git repository, that's perfectly supported within the platform as well, right? So if over here I'm going to go into this Delta Lake workshop notebook. All right, so I'm inside of the notebook, and notebook, as you have many of you guys have probably have experienced with other notebooks, you have all these cells where you can write your code, or you can do markdown. You attach your code to a given cluster, right? So your code and your cluster are two different concepts, right? Their life cycles are different. Clusters are ephemeral; they come and go as and when you want to run the code. Code, of course, persists for as long as you want, right? And the code can be backed into your favorite Git repository as you may choose to use your own Git versus using the version control mechanisms built into the Databricks platform. Yeah. So over here, I've attached this code, this notebook to this test cluster that I had earlier created before starting the session today. And again, I'm not going to go into the every cell of this particular notebook, but really just kind of highlight some of the key things over here. So here, first, I'm going to just go you and show you how easy it is to create Delta if you have existing Parquet files, or you have any Hive table. To create a Delta table from it is as simple as saying create table, right? In this case, I'm saying lone state Delta using Delta as before I had indicated. Rather than saying using Parquet, I just say using Delta, and then I do an insert as select star from a non-Delta table. That will end up creating me a Delta table. Yeah, so it's that easy to create a Delta table. Now, if I go further down in, again, these are code that I had previously executed right before the start of the session. So you can see that this completed, and this was the last time, which was earlier today, that I had run this particular cell. Now, it looks like the screen is a little too small. So let me see if I can make things be a little bigger here to make it be more readable. All right, let's see with this. So create Delta Lake, right? So creating a Delta table is as simple as saying just using Delta. Now let's go further down over here. And again, in the interest of time, I'm not actually executing the code. I'm just going to show you the code snippet and the results that I got from previous execution. Now, Delta, as I had said before, just like any data warehouse, has full DML support. Yeah, so if you want to do a delete statement, right? If you want to do a delete statement on a Parquet table, so this is a delete from lone state Parquet. This is basically table in Parquet format. If you try and run the delete command, it will fail, right? But if you do the same command on a Delta table, you see that it will succeed. So delete from lone state Delta, where address is equal to IA, or the state is equal to Indiana, you see that this job completes. Yeah, so Delta Lake supports full DML commands. And again, further down in over here, there is examples of how you can do updates and how you can do inserts. One of the things that is really helpful for our customers is the support for merge statement. So merge is basically if you don't have the data, then insert it. If you have the data, then you update it based on the new incoming data set. Right? This is a very common operation that our customers have to do, and anybody has to do on top of their data lake environment. So the command for that looks like this, right? So merge into the lone state Delta table, right? Using merge table. So this is the incoming table. Yeah, you want to merge it based on these criteria being the same, and then you say when matched, then you update, and when not matched, then you just do an insert. Yeah, and this basically takes care of merging your new data set into your existing data set, right? A very common use case that folks end up executing as part of their CDC ingest framework. Yeah, and I want to kind of go further down over here to show you a few other capabilities of Delta. Delta supports schema evolution, so it can enforce schema, or you can set it up to be either you can set it up as kind of schema is enforced, or you can set it up to be schema evolves, right? So if it sees a new column, it can actually adjust the schema on the fly for you. And here in the first case, what I'm doing is so let me go over here. Here I'm trying to write into a Delta table, right, in an append mode, and this is the path to the Delta table. It fails because the data that I'm trying to append does not comply to the schema. So schema is being enforced. If I want the schema to evolve, right, then I can simply pass that as a parameter to my write statement. So I can see over here now I'm saying loans.write.option merge schema equal to true, right? And when I give that option, you see that the job succeeds, and it took 6.3 seconds to execute. But over here, it was able to automatically evolve the schema because that's really what I wanted to do as part of this statement. And again, this becomes really helpful for our customers who want to have data quality, but they want to be more accepting of schema evolution in the landing zone, in the earlier stages of their tables, but further down the stream where they have their silver tables and gold tables, they would like to see more enforcement of schema. So it really gives them the flexibility to have a schema enforcement and or to evolve schema as data flows through the different steps within the data pipeline. Yeah, and then a couple of other things. Time travel. I talked about time travel. Delta supports time travel. Extremely useful, right? For recovery. If you want to do a reproduction of a scenario, again, time travel becomes invaluable, right? A very common use case for this is being able to reproduce your ML experiments, right? With ML experiments, typically you see that people version their code, they version their environment. But if you're not able to version the data set, then how do you really be able to reproduce it? And again, in regulatory environments where you need to be able to demonstrate and reproduce your results, Delta time travel becomes an extremely critical feature. Yeah, so over here, you can see that if I go into describing the history of a Delta table, then this gives you information about all the changes that have happened to the Delta table. Here you can see that I created the Delta table, then I updated the Delta table, then I merged the Delta table, then I wrote a set of records into the Delta table, the timestamp of when those changes were happened, and all the different versions that were created. Now I can go in and query this data set as of any given version or as of any given point in time. Yeah. So again, back to over here from a time travel perspective, you can see that this is basically querying the table as of version 0. And if I want to kind of query to a different version, I can simply specify a different version number. Yeah, so it's that simple to do time travel. The next bit I wanted to talk about was constraints. Yeah, so I talked about schema and schema evolution earlier on, but data quality is not just about schema and enforcement of schema. You also want to be able to check for the exact value of a particular field. Yeah, in some cases you don't want to allow a null, but in other cases you may say the value has to fall in between a certain range, or you may want to have constraints between columns of a particular table. Yeah, and with Delta, Delta supports constraints that is even more advanced than what you find within a data warehouse environment. Yeah, so over here, you can see that now I've created a test constraints table, right? And I'm adding the constraint that transaction ID cannot be null. Yeah, well, you have seen this with other data warehouses. But over here now, I can also go in and say add constraints where a cost column, right? The constraint is called valid cost, and it's checking that the cost column, right? The cost column over here in the table is greater than 0. Yeah, that's a simple check. You can actually also do constraints like this, which is that the cost column is actually greater than equal to tip. So you can start to compare columns as part of constraints that you define on top of your Delta tables, ensuring that you have quality data and that the analytics you do on top of it is as a result of high quality as well. Yeah, and if I try and insert a value where this is violated, where my cost is where my tip is greater than cost, you will see that the system will error out. So over here, I'm trying to insert transaction ID, the cost, and the tip, and it succeeds because my cost is greater than the tip. But in the next statement over here, if I try and do cost of 10 and tip of 15, it violates my constraint, and the result fails. Yeah. So these are the kind of guarantees that you want to be able to really build robust pipelines and to have really healthy data quality, and you get a lot of benefit and a lot of support from the system, and not everything has to be maintained by the programmer as part of the data pipeline logic. Yeah, and the final thing I want to show and talk about is Delta Shallow Clone. This is my favorite feature of Delta. How many of you guys run really large data lakes? And now if you want to build and refine your data pipeline, you have to either do it on a very small sample of data, or you have to do it in a way such that you basically end up taking risk on your live tables. Yeah, neither of which is really what you want, right? You don't want work on a sample of data, because in that case, your pipeline will not really cover all the real life use cases, and you really don't want to actually execute it on your live tables, because then it may impact production workloads that is currently happening. With Delta, we support the notion of shallow clones and deep clones. So shallow clone is where you make a copy of the data without really duplicating the data set itself, right? So we just copy the transaction log, and now you can start to query and run your pipeline on top of that shallow copy and modify the shallow copy without disrupting your original source table. Yeah, this is such a common problem across data engineering workloads. How do I really do the test and dev environment? It's not just about setting up a different environment. It's really about how do I get access to the data without jeopardizing my production data itself. Yeah, and with Delta Shallow Clone, you can easily create duplicate tables without creating another duplicate copy of data. Now, of course, there are requirements where you may want to do a deep clone, in which case Delta also supports that. Yeah, so over here, what I'm going to do is I'm going to go ahead and create a Delta Shallow Clone table. So you can see create table, table clone, shallow clone, test constraints. And now I can begin to query that clone table, right? I can evolve the clone table right here. I'm evolving the clone table, and this evolution will happen independent of the source table from which the clone was created. Yeah, so that's pretty much the demo I have. There is there are lots of things that I've not covered in this demo. I'd love for you guys to just go and investigate more, read up more on Delta table. I think you would find it to be extremely valuable to bring that reliability and consistency and data quality on top of your data lake environments.